Dr. Anil Rajvanshi, who has been very kind to us and has accepted our invitation to come here and be our guest of honor and present this institute lecture. So I'll read a very brief bio sketch. It in no way justifies the kind of accomplishments and the kind of contribution that he has made to our society. So Dr. Rajvanshi completed his BTech and MTech in Mechanical Engineering from IIT Bombay. He then went on to complete his PhD from University of Florida. He has received the Janna Lal Bajaj Award in 2001, the Federation of Indian Chamber of Commerce and Industry FICCI Award in 2002, and an Energy Globe Award in the AIR category in 2004. In 2009, he received the Global Award for Sustainability Research. In 2014, he became the first Indian to receive the Distinguished Alumnus Award from the University of Florida. He was also the recipient of Distinguished Alumnus Award 2022 from IIT Kanpur and was given one of the highest civilian award of Indian Padma Shri in 2022. He is currently the Director and Honorary Secretary of the Agriculture Research Institute, NARI, in Phaltan. He has been residing in Phaltan from the last 3 decades and has pioneered the development of technologies spanning a whole spectrum of areas affecting the lives of rural population, namely renewable energy-based cooking and lighting, power generation from agricultural residues, water purification, effluent treatment to the use of renewable energy. With that, I welcome Dr. Rajvanshi.
First of all, I would like to thank Shobha, telling her that I am a fossilized human being now. All the work that I will tell you now was done by me in the 70s and 80s. Since the last 25 years, I've been more focused on understanding the mind of God and understanding our mind, because I believe that that is the real future and the truth. And so I would like to take your indulgence, because what I will speak is 50 years old. So without much ado, I'll start. The title of my talk is, in fact, I would like to thank her, and also, I was very impressed that she and Sumit have set up one of the finest water technology centers, and I wish that it becomes one of the major centers of India for doing water research and development. Now, when she asked me to talk on water, it brought back very good memories. And I looked at things which I did, and I was very surprised to find that there are those things that I attacked at that time. Some of them are still unsolved, and so with the bright students present here, I would like you to again look at it. You are much smarter than I am, and I am sure that you will do wonderful things by looking at the whole issue of water. Not only its changes from from seawater to fresh water, how also it can be used in a much more sustainable manner. As she said, I run a small NGO called Nuclear Agricultural Institute. In fact, I don't run it. My wife runs it. She is my boss. In fact, she is the reason why I came to Phaltan. I come from Lucknow. So if anything that I have done is because of her. So you should give a clap to her. This institute was started by her father in 1968, another Padma Shri. In fact, I believe that we are the only NGO in India which got 2 Padma Shris. And he started the work in 1968. The whole idea was, can we do research and development to help the farmers? And all our work, in fact, what I will show you, is trying to solve the problems that I see in front of my nose and try to see what we can do with the limited resources. And another reason why I took her offer is because I love to talk to the youngsters, because I want you to come and help us. And so this is a very selfish motive of trying to seduce some of the youngsters to come and do internship and help our institute. Okay, where is the, can I just do it here? Yes. So, just a certain perspective, total projected water demand in India for 2025 is the Government of India statistics is around 810 billion cubic meter. Average rainfall over Indian landmass is 3,880 billion cubic meters. Our water requirements is only 20% of the total rainfall. Our rainfall is uneven and quite at times it does not fall where we need it. Hence, there is a need to develop innovative water management technologies. Anything that we do today is a water vapor management, because the great solar energy has evaporated the water from the sea, and rather than, as I'll tell you, since I was very naive and I went to do my PhD, I focused on desalination, not knowing anything better, so focused on desalination, but later on I realized that is the wrong end of the spectrum. Sun has already evaporated the water. How to utilize the water where you need it is the greatest challenge. Rainwater harvesting, which is a part of water vapor management. I hope that from here, the water vapor management gets into the vocabulary of the water people, and so this should be the focus. Locally and its judicious use is the only solution to India's water crisis. Against this background, I'll talk about our work and future possibilities. Our work on water technologies. My research journey started in US in 1975 when I went to do my PhD, and we worked on seawater desalination, the use of dyes, the high voltage surfactants to modify air interface systems. In fact, I hope some of the PhDs who are here, when you look very deeply, then you start looking at a lot of things. I was a maniac in that, and it was very enjoyable. So I took courses in surface physics, surface chemistry, took courses in electromagnetic fields and waves, just to look at what is the surface and how we can modify. And then we also looked at the use of sand, which is a very cheap solar collector for large-scale desalination. And then the very pioneering work that we did in the 1980s was the Duke Peninsula. And in all these things, my basic focus was biomimicry. At the time, biomimicry was not the word. People never knew what biomimicry is or was. And but I understood right from the beginning that nature has all the answers. It has millions of years of evolution. It has optimized, and if we follow, which means we should understand how it is doing and then try to follow it, then it will be very sustainable and very efficient. And this should be the mantra of development of any technologies and any research project. I came back in 81 like an idiot, left everything. I was a professor in America. Thought I was very arrogant, thought I'll change India. India is a very ancient society. Nobody has changed it. It changed me. It made me simplify my life. It made me focus more on spirituality. And it told me that the problems are so much that even in 7th generation we cannot solve it, especially the rural areas. And this is a challenge to all of you. Rather than focusing on a very narrow thing in your own areas, that is fine because it is also the development of the mind. But look around, see how your research can help this country, and especially the 60% of people who live in rural areas. So in Nari, when I came, immediately the problems that surrounded, so we started looking at, 1981, it was a very massive program by the government of Maharashtra on planting trees. They would give the seeds, people would, the forest department would plant, put the seeds, and nothing would come out because there was no water. So we developed a very unique technology. I'll show you how we took out the water from the soil by solar energy and fed it to the seedlings, and there was 100% survival. Then we looked at where I live, it's a sugarcane growing area. So there was a distillery, and it used to pollute because the distillery effluent is very obnoxious, it's black in color, very foul smelling. And so the problem existed right now, right in front of me. What can be done to detoxify this distillery effluent? So we looked at very interesting solar energy technologies, and we tried to solve it, and I'll show you. And then we looked at the water purification for using solar energy. Today in the rural areas, the worst problem is the water that the children drink in rural schools. How many of you are aware of the rural schools? Have you done water there? And you survived that itself is a God's grace. The quality of water is horrible. And when we started looking at it, we said, what can be done? And so we thought that the best thing is to rainwater harvesting and then purification through the solar system that we have developed, which is, I think, very unique. And we are now putting in a rural school with 200 liters per day. And if it succeeds, then it will spread on large. So this is something which I would like some of you to help us. I have requested Shubha to help us in this matter, and we'll talk about it. Oops. Oh, sorry. And then we are looking for good, dedicated engineers. Very little money. Remember that. But tremendous challenges. And you will enjoy, and you will remember your life because if it gets into your DNA, what happens in the rural areas, then you will be a great and better human being. And you can do wonderful for this country. So the first thing I did when I was doing my PhD was the use of dyes for increasing evaporation. Again, the idea came from the nature. We looked at how seawater gets heated up. And if you know a little bit, then the solar energy goes and absorbs in 1 meter and nothing else. And then the 1 meter which gets heated up and evaporates and produces the clouds and produces the rain. So we said, what can be done to duplicate it? And then we used the dyes. So this is 1975-76 work. And we used all different types of dyes. And we found a 20% increase in evaporation took place. This was again the duplication of seawater by solar energy. Now when I was doing all this, I suddenly started thinking, what happens to the interface? Water is a molecule, the water-air interface is very interesting. If I can change the, it's a surface tension, then I should be able to evaporate it. So we looked at surfactants, we change the surface tension, and then I looked at the high voltage physics. I started playing around with 20 kilovolt, different frequencies with surfactants, and we did some very interesting work. And we found sometimes almost 300% increase. Not every time it was duplicated, but something happened. And then my professor gave me an ultimatum. He said, I need a PhD, not a Nobel Prize. You better finish your PhD. So I went back to my total rudimentary clerical type of thing of putting different dyes. We did also very interesting mathematical modeling, and we were able to. But that is something which you have to deal with, because the water surface is a very complex process. And even today, if you do the energy balance of the evaporation from the sea, the amount of energy that is following, by which you can calculate the amount of water that will evaporate, is not the same. In fact, water evaporation is much more. And so we do not know whether the plankton playing some major role at the surface, where it is increasing. And this is something that needs to be looked at. It's a great challenge. So I don't look at it now because my mind is somewhere. It's very challenging things for some of you. Then when we are doing this desalination work, I said, what should be the cheapest way to desalinate on a very large scale? And I thought that the desert sand itself can be a great collector. So we did a lot of experiments of putting the pipe in the sand, then heating it, and we found it was very efficient. And in fact, on a large scale, we developed a scheme which was published, and all these things were published in 1979-80s, where we did a very interesting, simple cement pipes buried in the sand, and they were able to, in the flash evaporation, you have very large desalination systems. But there are very interesting future R&Ds. First of all, again going back to biomimicry, there is a need to duplicate mangrove root technology. Mangroves are the best desalination systems. They have a minus 42 atmosphere turgor pressure, so the water that comes through the root system simply removes all the salt, and then the water comes into the plant. How many of you looked how the water travels in the plant? Why the water goes to 200 to 300 feet in a very tall trees? It's a very remarkable technology. There is no moving parts. The evaporation of the water from the surface of the leaf is a pump. The water is in the molecular form. And so there's huge, fantastic things that go through the phylum of the tree. And if we can duplicate, then that will be a fantastic water pumping and also the reverse osmosis. Not only that, the root system of the mangroves. Hello? The root system of the mangroves, it never gets clogged. We look at membranes, and when we have these RO systems, after some time we have to change the membrane. The root system is a self-cleaning process. And this is something which you have to look at very nicely. Second is, just like the mangroves, is a seagrass. Seagrasses again are grown only in the seawater. The surface area is quite large because of evaporation. And so I got the seagrass from Chilka Lake, did some work, and that is still again, these things I left. This is a great challenge. You can have the seagrass evaporating the water, the surface area increases, the water evaporation is much more. We saw that it was almost two times more than the regular open surface. And then you can also produce biogas by fermenting the seagrass. So it can be a very nice and closed system for producing water and energy. And then the understanding the seawater surface and the role of plankton in water separation, and understanding the cloud physics. So when I started looking at the evaporation of water, I found that the evaporating water is a charge system. And when you goes to become the cloud, you still do not know how the top and the bottom changes take place, and the lightning. There was a very famous cloud physics professor in University of Florida. I used to go and discuss, and he said, we don't still know what happens, but lightning helps in cloud seeding. And you still do not know, but it happens. So these are the things that are so challenging. It is work for people to look at, and that is how the new development and great breakthroughs come. And then the implications for weather and environment. And not only that, it's a very interesting thing. We talk about weather changes. We say so much rainfall suddenly has started coming here, so much dryness here, etc. The amount of solar energy on this planet Earth is constant because sun has not changed. The amount of clouds that come out of the sea are also same. What has changed is where they rain. And I think one of the reasons is because of the changing magnetic fields of the Earth. These are charged particles. It is possible that they are changing their pattern, and it will be worthwhile for us to understand why this is happening, and then use it for our purposes. Then there was a dew collection. I read a paper in 1979 about this beetle. This is a dark beetle. This had just come out, where it collected the dew at night, and in the morning it would drink it, and that's how it survived. So suddenly an idea came, this is a fantastic way of really using the water dew for drinking purposes. Looking in the literature, I found that there was no thermodynamic data. So we developed a complete thermodynamic data of dew condensation at different temperatures. So this experiment was done for 6 to 7 months in Florida, and we developed the whole heat transfer, mass transfer data. And this was published in 1980. This was, by the way, the first paper on dew condensation for large-scale water production. My staff in the University of Florida said that I should have patented it. I said it should be available free because after all, water is free. Nature has evaporated, so why should I patent it? And today is a very multi-billion-dollar industry. People are putting these interesting systems where they condense the dew by small-scale refrigerators, etc. And so this is a very big industry. But I feel very happy that we were the first people to start this process way back in 1980. Based upon this, we developed this very interesting scheme where, at the bottom of the ocean, the water is very cold, 6 to 7 degrees Celsius. The dew is already there in the coast. So the idea was to pump that cold water from the sea, pass it through these collectors, and they developed all the heat and mass transfer data and collect dew. And then this water would go into the soil in the ponds where the marine culture would be done. And the water, same water, which is warm now, would go down. And very interesting things we developed on what is the pipe diameter, what is the pipe structure, etc. Because by the time it comes in the top, it should not heat up. So this was very interesting, and I think if you go to the original paper, you will read, you will find out all the things. What are the future R&D? There is a need to duplicate Spanish moss, aeroponic systems. Have you seen a Spanish moss? Have you seen these small things on the trees? At least in Florida, there were a lot of Spanish moss, and they take all the material from the air, water, nutrients, etc. The tree simply acts like a structure where because they don't have very good root system. So there is a need to understand how it happens. And nature does a lot of very fascinating things. Keep your eyes and ears open. You are next to the lake. Go into the lake. Go around the lake. Find out what is happening. Look at the things, and you will find a lot of very innovative things. Do that rather than sitting in your small things. Or in fact, don't even sit. You play with the mobiles all the time, for the social media, etc. Dew itself is a charged particle, and if we have a charge collection surface area, then the increase in dew efficiency can increase. Now there are a large number of places all over the world where they are collecting dew, but they are not looking at the dew from this charged particle point of view. And I think it is something which can be done by our students. Then we also looked at the floating dew collection plants on the sea, because after all, sea has already evaporated the water. So you have the dew collection systems there. You can collect the dew, put it in a plastic huge bag. Water is lighter in density as compared to seawater, so it will float, and then you can drink it. And this can be a very good thing. And our calculations showed that the whole coastal area of India can provide 50% of our drinking water demand for this country. This is a very big calculation, and it is something worthwhile. And you are in the coast area, maybe set up a small experiment and see for yourself how things are. Water harvesting from clouds via kite scheme. This is a dream. So when I was looking at all these things, I came to Phaltan. Phaltan is in the rain shadow area. Sahyadri range is very close to Phaltan. All the clouds that come, they climb over the Sahyadri range. They don't fall in Phaltan. They go all the way to Deccan Plateau and then they fall. So I thought, maybe can I suck these clouds? And an idea came that you can have a fantastic kite. The kite string will be like a tube. You suck the clouds and you condense it just like a tube. This is a dream, and I'm sure some of the smart students, people can do it. This is far better than cloud seeding. Are you aware of cloud seeding? So the father of cloud seeding I knew. He was Vincent Schaefer. He was in General Electric, and he was an assistant to Langwood. He was the first industrial chemist who got the Nobel Prize. So I started talking with him. Those times we could only send letters and talk on the phone. And he said that cloud seeding is very dicey. It is never for sure, because you can see the cloud, where it will fall, the rain, nobody knows. And this is exactly what is today. Hundreds and thousands of experiments have been done all over the world. And it is a great scheme for the politician, because you spend money, you send the plane, you put in the particles, where it rains, nobody knows. But the money has been spent. But I think this cloud, from the active harvesting of water from the clouds via a kite scheme, may be something worthwhile. Then this is a very interesting thing that we did. As I said, there was a very large program by the government of Maharashtra for tree plantation, and the trees, the saplings, don't have, the roots are just when they start, they don't have enough energy to suck in the water because water is very deep, so they die. So we developed this very interesting thing in which we dug up a 1 meter by 1 meter pit, we covered with the soil, and the water which is already in the soil, it is heated by the solar energy, it evaporates and condenses in the glass, and we collect in the bottle. And then we give this water to the seedlings, and it was 100% survival. We did the experiment for many years, and in fact we developed the whole basis again of the thermodynamic data of heat and mass transfer on how much water you can collect, because people said if you collect it 1 year it will dry up, but we did it for many years, and the cycle is there because the rainwater comes and etc. So water bound in the soil can be harvested by solar energy. Pit size was so much, and 2-year continuous experiments in the dry area of phaltan, and average production was around 300 milliliters per day per pit, and 100% seedling survival. We did for many things, Lucina, Prosopis, so many different trees, which was 100%. Trees did not grow very much, but they survived. In life, it's a survival which is the most important. The growth comes later on. We gave this technology to NDDB. Kurian came to know about it, so he invited me. And Nandini. So 1990, we spent a couple of days with him, and his team had come. And they said that their biggest problem is, they make a lot of salt, NDDB. They have the whole Kutch area, and they said we don't have enough good drinking water. So they use this to put over the water table is very high, but it's all salty. They put this type of thing, and they collected water. And so it was very useful. I don't know what happened here. And this was published in Solar Journal 1990, and some of you can read it. Then again, since this distillery is very close to our house, which used to pollute the whole at night, it would be horrible to sleep with this pollution. So we said, what can be done to detoxify this waste? I was working in solar energy, so I said, let's look at it. We had already been correspondents, this is 1990s, and people had just started looking at titanium dioxide as a photocatalyst. So we said, we'll do it. We did a lot of experiments in titanium dioxide and so many other things, and did not find anything to do with titanium dioxide. 15 liters of effluent is generated per liter of ethanol produced. A very huge amount. It's absolutely black, foul smelling, very high in biological and chemical oxygen demand. So a 200 liters per day pilot plant was set up in our institute in 2000. And we found that magnesium oxide acted as a photocatalyst. People were very surprised. I was very surprised because by the time I had gotten enough knowledge about what the photocatalyst does, and I could not explain, though there were certain things that we could do with the solid state physics, but magnesium oxide did wonderful things. Transmittance was changed from 0 to 90% in 2 days, and 95% of catalyst removed. So after the catalyst, we then filtered it, heated it at a high temperature, and it would be recycled. And we did it for a couple of years, almost 2 years. The COD reduction was by 98%. And the treated effluent was successfully used on various cotton plants. So cotton, bhindi, etc. We used it, and it was quite good. This was the plant. Very simple. Stainless steel. You had the photocatalyst, the distillate effluent, naturally diluted, and this is the. So the left side is a rock, the right side is I can't read. So it's a solar treated. Then after 2 days, and then when you filter out the photocatalyst, it becomes quite not completely clear, but quite clear. So I called the distillery effluent. They immediately did the calculations. They said it's no good for us. So I said, why? It is too costly. In any way, they were putting the dirty water in the canal without any problem, because there was nobody to question them. Now there are more stringent laws. At the time, they were not interested. So 2-3 disciplinary people we discussed, and finally we didn't take it up. I'm sure now with more stringent laws, somebody can take it, people can take it. Then, when we started looking at the schools, we saw the rainwater harvesting. Because see what happens that if you take the water from the ground, there are so many salts, there are so many other things, and that is something which we cannot take care of in our system. So we said we'll look at the rainwater. And in fact, all our work is for water vapor management. So if we have the rainwater and then we treat it to make it completely clean and drinkable, then what is wrong with that? Yes, there is a cost involved in the rainwater harvesting, tanks and etc. But there's all this Jal Mission and etc. It can be taken care of. So we developed this technology where the rain, there's a small hut in our institute where the rainwater comes, then it is collected in the tank, then it is another tank. The rainwater has color because the tannins, the leaves, etc., which fall on the roof, they take the color from that. So we have developed a very simple, low-cost filter, and that has been working for almost now 2 months, and the color is completely transparent. We want to see how long it will. It is very low cost, and we can just remove and put it together. And from there, it goes to our solar purifier. So this is the system. This is all the purifier, etc. This is today. It is almost, I think, 1.5 months. Left is the water which comes from the tank, from the roof, and the right is from the filter. It is not clean yet, and remove that filter. And this is the purifier. Now, purifier works on a very simple principle. We did a lot of experiments, almost 3, 4, 5 years. We filtered the dirty water through a sari cloth, 8-layer sari cloth. And later on, we did all the experiments on what is the pore size and etc. We remove as much as possible, and then this is the heat which kills all the equipment. And we tested in our microbiological lab, and we are asking Shobha to also help us in this. And we have been doing for the last 3-4 years, and we find that it is a completely like mission. And the funny part was at 45 degrees Celsius for 3 hours, because the solar tubes, they keep the heat very efficient. And at 45 degrees Celsius for 3 hours, everything is clear. The implications are amazing, because on a completely cloudy day, even with a slight shower, you get 45 degrees Celsius. For the last 3 years, the data we have collected, we find 5 to 6 days maximum in a year. We get temperatures which are below 45. So very simple technologies, a lot of thinking, a lot of deep thought can have a tremendous implication. And these are not simply research for the research sake, this is for solving the real problem which exists around you, which you can see all around. Even in your, how do you get water here in Mumbai? It's all treated. In the hostels, it's all treated. Huh? BMC, so you trust BMC. I'll tell you a very interesting story about BMC. Can I have water, please? So this is a very powerful treated water. Eh? And the interesting part is that this water is 87 paisa today. If I spend the money on the water tank and etc., 87 paisa per liter. And if we have this Jal Shakti mission, etc., then it will be almost free. So, and this is what, 10 rupees per liter. So in 1986, I was invited by the Commissioner of Bombay Municipal Commissioner and his team, because at the time the Prime Minister was Rajiv Gandhi. And Rajiv Gandhi had sent a message that there are indications that Pakistan will poison Bombay water, the lakes and etc. So we should have a desalination system. So I got a letter that you are an expert, God knows from very new that I was an expert, I didn't know anything about. He says, can you please come and give us some advice? So I go there. There are a 15-20 member team of Bombay, all the engineers, chief engineers, etc. So I tell him in 86, 87, I think, that Bombay gets so much rainfall. Every society, every building should have a rainwater collection system. And we should then, modify it, we should purify it, and then we should also have dew condensation, because all the air conditioners. So they all started laughing. He said, did we invite you from phaltan to talk about these riff-raff and stupid things? This was the chief engineer. This suddenly dawned upon me that they were looking for something else. Then I told them that there are floating desalination plants by this Swedish company, and they immediately jumped because the whole caravan went to Sweden to look at the technology. So this is India. Nothing has changed. We don't look at the real solutions, we don't look at the good solutions, because we don't want to use our brain. And when we don't want to use our brain, then we'll go for all these things. I was the chief guest last month in HAL Nasik, where we make Sukhoi and all these aircrafts. So we gave a very grand tour after my lecture. So I said, why can't we make these things? Why do we have, Sukhoi at least they were making it. Rafale, they are not making anything. They are just simply importing it. Why? We are the people who talk about the third biggest economy, the biggest brain. You are the people who will go and run Google and Microsoft. Why can't you do it here? Why can't we change the atmosphere here so that we can do wonderful things for this? This is a challenge. So get out of your comfort zone, look at the technologies, look at things, and let's change the world. So we are putting a 200 liters per day unit in a rural school, and you can read all about this. This is published in Current Science. Now this is another very interesting technology that we are proposing for talukas. Because we have worked, in fact, you are the people who developed the policy for taluka energy self-sufficient in 1990s. And the biomass-based systems came from our work that we did in those times. And so I have always looked at taluka. So what I feel is that in taluka, if we make these small ponds, and I don't know what the size of pond, and AI is so powerful now, it should be able to tell you, all you guys work all the time on AI. This is the challenge. Do the AI analysis, find out what should be the pond area, what should be the collection area, and how many ponds. And this will be like every pond is like a battery inverter system. When there is no electricity, you use the battery and inverter. Same thing with these ponds. So when there is a rainfall, you collect the water. There is excess rainfall, put it in the canal or the river. You take it from the canal or the river, and you can see that this can become a very major source of water collection and for helping the water problem. And the soil excavated can be used for agriculture and in construction industry. So many bricks can be made, so many things can be done. This is a very good soil. And I feel that the issues of ownership and energy sources, water pumping, needs to be looked at. And this is where you people come, because you all the time love to stay on the computer and do it. Do it. It's a very remarkable thing. And if we take one project and find it, if it works, then it can spread like wildfire all over the country. So in conclusions, water is the most precious source. We cannot survive more than 3 days without it. You can survive without eating, you can survive with so many things, but water and the future wars. In fact, it's very remarkable in 1979 when I wrote my thesis, PhD, I wrote in my introduction that the future world will have water wars, not energy wars. Though I was working in solar energy. Because water is the most essential source. All of us know. And so this is very precious. We should be working on developing it, recycling it, and not wasting it. Need to conserve it and recycle the wastewater, first step towards sustainability. When you talk about sustainability, and all the time you people are talking about sustainability, water sustainability is the most important. I am very inspired by the example of Gandhiji. My father went to jail with Gandhiji in 1940s, and so that was also one of the reasons. And Gandhiji said that you have to practice what you preach. And I tried to live, or both tried to live a very simple life. I've written it up very nicely. There are papers on that. And how are you? And I have done all the calculations. And in 1/4 to 1/5 of the energy that is consumed by an average American, I live a very simple and a very emotionally satisfying life. And I don't live in a joke-body. With all the modern technologies I live. And we have also done the water analysis. And we normally use 180 liters per day per person. It's a very reasonable amount of water. So if you do this thing consciously, all of us can become sustainable. There is I think, a department of sustainability here. I don't know what at least in IIT Bombay it is. And I tell them that the only way you can do sustainable is you make your department completely sustainable, your different coastal sustainable, electricity, water, etc. And everything will become sustainable. That is what Gandhiji preached. If each one of us, a small unit, can become sustainable, the whole world will become sustainable. Most of the tap water in India is not fit for drinking. This is one of the data that I have collected. If I am wrong, you can blame that data, not me. Only 3% of households drink piped water, which means without doing anything. Need innovative solutions to make it potable. More than 50% of rainwater goes to sea, also leads to fantastic soil erosion. This is a very big problem in rural India. You have these very flash floods and all the soil is gone. And by those water ponds, we will not only save the water, but we will also save the soil. And that is the most important. So these are the challenges that exist not only in other places, but mostly in rural India. And I would really request some of you to accept these challenges and see what you can do. Actively using water vapor management, which includes rainwater harvesting, dew condensation, and cloud management strategies for most power users, is the way forward. History of civilization has centered around water resources. You all know. All the great societies, all the great civilizations came around great rivers. Nile River, Gangetic River, Yangtze River, all over the world. Amazon River. And it will continue happening the same way. We should not fetter it away. For India to become a great and powerful nation, efficient use of its water resources is necessary. Thank you very much.